All right, folks, remember, if you haven't done it up until now, go ahead and do a git add, git status. There's a whole bunch of stuff here. Git commit, learning up until, this point. Whatever you want your commit message to be, and then I'm just going to go ahead and do a git push. And now let's continue forward. In this lesson, we're going to be learning about sets. Sets are an important data structure in programming and computer science because of some of their properties. And sets kind of look like this. I'm just going to call this, desserts is equal to, and then the way you do this is actually with curly braces, just like with dictionaries, but instead of having pairs of items, you're just going to have individual items. So I'm going to have ice cream, I'm going to have donuts, I'm going to have cake, and then another dessert, which is probably going to be, how about wine? Yeah, there you go, wine. So when I print out my desserts, you can see that I've got a set denoted by these curly braces and the individual list of items in here. So this is not a dictionary, to be clear. Now you can see here that a set is very similar to a list, right? It's just a list of items. But there are certain qualities about sets that make it very different than lists or arrays. The first is that this is unordered and unindexed. If I try to access index 0, for example, I'm going to get an error because it says a set object is not subscriptable. And so what this means when people say that the set is unordered and unindexed is that when you insert items into the set, the order in which you insert them doesn't really matter. It doesn't get preserved. So if you need to preserve the order in which you add things to stuff, the set is not your go-to. You're probably going to want to use a list or an array for that. More importantly, the second quality of a set is that the elements in it are unique. Okay? So if I really quickly print out desserts again, if I try to add desserts.add and then I try to add ice cream again, look what happens. Nothing happened, right? Because ice cream already existed inside the set. And so that's the second thing that you need to remember about sets is that the items within the set are unique. And because of these properties, you can use sets in very advantageous ways when you're solving problems. Okay, now I mentioned that you cannot iterate through the elements in a specific order that you expect in a set, but that doesn't mean you can't iterate through elements in a set. So if I do for dessert in desserts, and then I just do print dessert, I am going to get wine, ice cream, cake, and donuts. See, like this is just kind of a random order. When I first created this thing, I had ice cream, donuts, cake, and wine, but now it's wine, ice cream, cake, and donuts. You see how the order is just like totally random? We have no idea what it uses to specify this order because there really isn't one. So that's case in point of that example there. Another way you can actually create a set is by taking a list and then creating a set from it. So if I create a list of desserts, dessert list is equal to, for example, if I have ice cream, again, why don't I just copy this? If I just copy these items, and then let's say I have another thing of ice cream in here, right? If I print out my dessert list, you can see here that I have ice cream twice, and so lists don't care if you have the same item multiple times. It's just a container with things in it, right? But if I take a new set, and then I use the set function set, and then I pass in this list. Now if I print out this new set, you can see that it automatically got rid of the second ice cream for me. And so that's another way to create a set right there. When you do the set.add, that inserts an element into the list, but then you can also construct a list, or you can also construct a set from the list by passing it in. So that's what I did here, and then you can see it automatically removed the duplicate item. All right, clearing the screen here. Now, just like with dictionaries and lists in Python, actually, you can check if elements are in the list, right? If I do ice cream in desserts, then you can see here that that results in true, which is great, okay? There are some other functionalities that are pretty common between sets and lists and dictionaries. For example, you can always get the length of the items inside the desserts, and so this set has 4 items, right? Now, earlier I showed you how to add items, right? If I do desserts.add and then I do fruit, then now you should see desserts with this stuff. Oops, fruit is the only thing that is capitalized. That's my mistake. But if you want to add multiple items, the set actually has an update method. And when you use the update method, it actually expects a list of items. And so if I add a list of items, for example, if I add chips, and then I add cookies, and then I add muffins, or something like that. So now after running that, now the desserts set has all of these items. Now, can I change the items inside the set? Well, kind of yes and no. Technically speaking, yes, you can change the items that are within the set, but you can't directly modify anything because it's just like a key that's immutable, right? And so if you want to, for example, change cookies to something else, then what you are actually going to have to do is you're going to have to remove cookies. So in order to do this, I have a couple different options. I can use the set.remove function. So if I do desserts.remove cookies, now you can see that cookies is no longer in there, right? So you're going to have to remove the item and then add a new item in order to quote-unquote change it. You can't directly just modify cookies or whatever other thing that you wanted to modify. There's another function that you can use to delete items, or another method that you can use, and that is the discard. If you do discard, let's see here, I'm going to go ahead and discard donuts. Now, what's the difference between these two, right? Because it seems like they both do the same thing. Well, here's the difference. If I use remove on something that doesn't exist, right? Right now, these are the items that are in my set. If I try to do remove cookies again, you can see here that it's going to throw me a key error. However, if I do a desserts.discard cookies, it runs just fine. And so why is this needed? Why is this necessary? It largely depends on the application. I can't really give you a specific example right now, but sometimes when you're writing apps, it's useful to have a function that doesn't care if this item is in the set or not. We just want to make sure it's not in there, and so the discard is a better function. On the other hand, if we need to make sure that something is in here and then we actually physically remove it, then that's a better use case for the remove function. So yeah, you could alternatively also use the pop method, which you have seen used in the lists and dictionaries as well. However, the problem here is that you have no idea what order stuff is going to get removed in, right? Because you don't know what order the items are in. Remember, the set is unordered and unindexed. And so every single time you run desserts.pop or whatever, you're going to get something totally unexpected. Now, it seems like it's ordered because you've already seen it printed out, but the problem is that I have no idea, or you have no idea, what was used to order these items in this specific way. You know for sure that when I added these items, they were not in this order, right? When I first added these items, it was in this order right here: ice cream, donuts, cake, and wine. And then I added more items: chips, cookies, and muffins. But then you can see here that the order has been completely botched: cake, chips, and then donuts, yada, yada, yada. And so remember very carefully that whatever is in a set is not going to have its order preserved. And so that, folks, is a set. Now let's take a look at one more useful piece of information about sets. If I have another set, for example, and I set this equal to, cookies, muffins, and then let's call this also ice cream, right? Now, what I can do is I can actually do a desserts.update desserts2. And now what that will do is it will take all of the stuff in desserts2 and insert it into desserts. And so the update function here can also, it can take not only lists of items, but it can also take other sets. All right, so as you can see here, another really useful function in set theory is actually the union function. And so when you union two sets together, you're basically just combining the two. Now, because of the qualities of sets and how they work, when you run an update between two sets, that's basically the same thing as running a union. the union just combines them together. And so you can see here that when I run desserts.union with desserts2, then I get all of this stuff together, right? So that's also really useful. Now, what happens if I, on the other hand, let's create another one called desserts3, and I'm going to set this equal to, I'm going to call this, what dessert is not common between the two? I'm going to call this cake, and then I'm going to say cookies. Okay? So desserts has muffins, wine, cookies, and ice cream. Desserts3 has cake and cookies. If I do an intersection between the two, intersection is another useful thing in set theory. An intersection between two lists or two sets will give you the common elements between them. And so when I do desserts.intersection desserts3, what do you think the answer is going to be? Well, between the two of them, there's only one element common, and that's cookies. So when I hit enter, I should get a new set that contains only cookies right there. All right, and so those are all the functions that you can use with sets. There's a lot of them. They're useful in different ways, and they're useful for solving different problems. So in the next video, let's explore an example problem.